Hey, so this should be kind of interesting. What I have here is kind of the uncreatively named Reload, and for some godforsaken reason that's spelled RE:load. This is a little, I think it's 15 watt programmable load that I bought from a company called Arachnid Labs in the UK. They ship pretty fast. I bought this last Saturday and I just got it now. It's, that was 8 days? Not bad from the UK. But anyways, it comes as a partial kit, and I figured, you know, there's some stuff I need to do. I want to do some load testing. One of the things thinking about is capacitive dropper offline power supplies. So, bought some bits to build a couple of those, and I bought I think it was fairly inexpensive. I think it was $15. It's an inexpensive electronic load, which should be, you know, it's more than powerful enough for what I want to do. So, that is everything in the baggie. What the hell is this? The fuck? So they're business cards. Why would they send me 3 business cards? And, oh brother. Isn't that just silly? Somebody needs to have, I don't know, maybe they need to come up with another product or something interesting. So you get a heatsink. They sell 2 versions of this, one for 15 and one for 25, and the only difference between the two is the size of the heatsink. And I'm probably going to mount this in a complete box anyway, so, you know, I don't think I'm going to keep it as a bare board, so I'm kind of like, alright, don't really need that. So you can see it comes, all the surface mount stuff, pre-populated. One of the nice things about this is it's open source hardware, so you can go take a look at the schematic. So you get the board, you get this, which is a BTS141. This is actually a very unusual device in that it's basically a power FET, but it's got a lot of other stuff. It's got like built-in thermal regulation, or thermal protection, and, you know, all sorts of other fancy pants stuff. So you can't, basically it takes a lot more work to, you know, meaningfully damage it than it would otherwise. You can see other stuff on here. We have current sense 1 amp equals 0.1 volts. So it's basically, obviously you can see it's got a 0.05 ohm resistor on it. Actually, let me change lenses. So here's our board. You can see that this is an MCP 60021, and that's basically just like an ultra. It's a rail-to-rail op amp. It's just a cheesy, or well, an inexpensive, decent quality rail-to-rail op amp. You can see it's got, I'm pretty sure that's actually a voltage regulator. I don't remember off the top of my head, but I don't know what else they'd be using it for. Particularly since it's got this little self-power jumper here, which goes to one terminal of it. So I bet that's like an LM1117, you know, 1117 or something along those lines. You've got 2 big-ass holes there, which are where these 2 banana plugs go. And then you have that's nice of them, they've got, well, I'm not sure if this is to allow the one board to hold 2 different heat sinks, or, you know, other things. I'm definitely going to probably, you know, I think I'm going to put it together on the board for the moment, and then I may, you know, mount this externally. I need to buy another nice aluminum box. Actually, yeah, so I have one of those, let me change lenses. So this is a very nice, remarkably inexpensive aluminum box I bought on Amazon for a, I have one of those RTL, some number based software defined radios. It's actually a TV tuner. And this is just kind of a box I put together to hold it. It's kind of messy internally. But this, I think it was only about $10 or $15, and it's fairly heavy aluminum, so I could very easily just buy another one of these. I mean, you can see that's got some heft to it, and then mount the FETs to it. And then this is just a one of these little things, and then I just have a header to a USB stub, and then this is just an SMA to MCX. These are incidentally fun. If you have 20 bucks and you want to play around with stuff, buy one of these, the Realtek based software defined radio dongles. They're actually TV tuner dongles, but they work as software defined radio. It turns out that the chip can be run in a different mode as a software defined radio with like 2 megahertz of bandwidth, and most of them are tunable from like 50 megahertz to 1700 megahertz. And the best thing is they're like $15 on eBay. They're definitely great for somebody who wants to play around with RF. You know, and there's some nice, really nicely written tools for using them, you know. Yeah, so anyways, yeah, I mean, it's definitely not as nice as a proper, you know, like a real high-end programmable programmable load, but also 15 bucks, you know, so I'll deal. So I mean, for $15, I'm willing to put up with, you know, a little bit of inconvenience because it's so cheap. I'm happy that I just got this, because this means now I can work on some of the, I need to do some design verification for some capacitive dropper power supplies before I go much further. So I think you can also, I'm not too sure what it takes because I'd have to mount the power remotely, but I can always just desolder it later on. Anyways, are the usual whole assortment of holes. You can put it like that, or like that. I'm going to put it basically in the topmost hole so that I have as much of the legs left as possible. I'm also not going to really use heatsink paste because this heatsink's not that big and it's probably kind of unwarranted. Actually, that's a good. So you can see this clearly has a front and a back. Though because this is not a TO like 247, I could mount it on either side. Ah, fuck, I have to buy metric nut drivers now. Why can't we just all switch to fucking metric? Or fucking standard, I don't care. I don't care which one we use. Can we just have a standard now? Please. It's barely peeked through. I don't know if I don't think I'll even tack the heatsink down. I'll just solder the pins of the device. Anyways, bring down my iron. So I didn't spend a lot of time. I mean, I did. You can see that they're clearly wetted through on all 3 pins, which means I have a fine connection. I didn't spend as long on the pins for the pot, mostly because they're not necessary because they don't carry any current. So, you know, having to use the walls of the via as a, you know, for conductivity is not a problem with those. Actually, are these metric or standard? Looks like they're. Annoyed. This is why we can't have anything nice. So normally I'd try to, you know, I'd take these tabs off and just get rid of them, but because I'm probably going to install this into a box where I'll need those tabs, I'm leaving them on. So, there we are. So, let me set that to 6 volts at low current, and then I'm going to assume that clockwise is reduced current. So, whoops, my voltage is really low. 10 volts. Cool. Seems to work fine. The range is kind of fiddly. I'm going to need to get a multi-turn pot. But hang on, let me change views and I'll show you what's going on. So obviously here we are. Load here, power supply, and I'm just using the built-in current meter just because lazy. But you can see that it's obviously, I mean, it's touchy. But I mean, I can set a current and it pulls that current. And then you can see now it goes into. So the minimum voltage this thing can handle definitely warming up a little bit. Looks to be about 2.5 volts. That's the dropout of the system, which is presumably when the op amp stops being able to bias the FET on sufficiently that it can pull current anymore. And there's actually, I believe you can power this with an external adapter, which would let it sink down to 0 volts. You know, basically large amounts of current at 0 volts. But I suspect that's a you know, basically just because it's parasitically powered. It's a little warm. It's not surprising. Right now it's dissipating 10 watts. It's hot to the touch, but I can still touch it. Yeah, it's a cool little programmable load. I just don't really understand why, I mean, full scale is 3.7 amps. So it's definitely a pretty chunky little sucker. So incidentally, also this is supposed to be 15 watts, but obviously I was just pulsing it up to 30, 40, 45. Ooh, it's definitely warm now. So, I mean, definitely the current carrying capability of this is rather conservatively rated. And I'm pretty sure that it's thermally constrained as well. Because you can dissipate a fair amount of energy in a TO220. At least for short duration, so you should be, I mean, it seems like it would work fine for pulse power consumption. And I will put any sort of details down in I'll put details down in the description, and like a link to where you can buy them. It turns out they're selling on Tindy, which is an interesting little site. And I hope you thought this was interesting.